All right, we're going to be doing some more examples of the washer method. For our first example, we're going to rotate region S around the x-axis. Now, if I rotate region S around the x-axis, the little radius is going to be this one here, and the big radius is going to be this one here. So let's write down what that is. Again, it's always going to be the top minus the bottom. So the top is the sine function, and the bottom is just the x-axis, so that's just going to be y equals 0. So it's just going to be minus 0. The little radius, the top is going to be 1/2. That's y equals 1/2. And the bottom is just going to be the x-axis, so that's y equals 0. So we're just going to do minus 0. So I've drawn one of the washers here, just as an example. And we want to fill in these washers from x equals pi over 6 all the way to x equals 5 pi over 6. So those are going to be our bounds. All right, and that's it. We're pretty much done. Let's plug in the big R and the little r. Okay, that's our final answer. Let's go ahead and put a box around it. And now we're done. Let's take a look at example number 2. For example number 2, we're going to rotate region S around the y-axis. If I do that, my little radius is going to be right here, and my big radius is going to be right here. Now this one's a little bit tougher because the equations are solved for y equals. I need them to be x equals because I'm doing right minus left. So I'm going to need to solve both of those equations for x equals. So now I can replace y equals 9 minus x squared with x equals the square root of 9 minus y. And now I'm going to replace the y equals 9 minus 3x for the x equals 1/3 9 minus y. And now we can do our big R. It's going to be right minus left. The right is going to be square root of 9 minus y, and the left is just going to be 0. For the little radius, the right is going to be 1/3 9 minus y, and the left is also just going to be 0. So we don't need to put the minus 0. I drew one of the washers up here just so you can see the orientation of the washer. And we are going to fill in these washers starting at 0 and going all the way up to 9. So those are going to be the bounds. Our bounds goes from 0 to 9. So now we're basically done. We just need to plug in the big radius and the little radius. There we go. We plugged in the big R and we plugged in the little r. So now we're done. Let's just go ahead and put a box around our answer. And that's it. Let's go have a look at question 3. All right, for example number 3, we're going to go ahead and rotate region S around the x-axis. You'll notice I put this little symbol here. It says we're rotating the region S around the x-axis. So our little radius is going to be this one here, and our big radius is going to be this one here. Let's go ahead and write down what that is. The big radius, I'm going to do top minus bottom. So it's going to be 8 minus 0. And of course, that's just going to give us 8. And for the little radius, I'm doing top minus bottom. The top is 4 square root of x, and the bottom is just 0. Of course, we don't have to put minus 0. Now I shrunk the graph a little bit so that I could draw one of these washers that turned out to be pretty big. And I did that so that you could see that we are going to fill in a bunch of these washers going from x equals 0 all the way to x equals 4. So those are going to be our bounds. Our bounds are going to go from 0 to 4. And now all we have to do is plug in the big R and the little r, and then we'll be done. There we go. We plugged in the big R. The big R was 8. And we plugged in the little r, which was 4 square root of x. And that's it. That's our final answer. Let's have a look at question number 4 now. For example number 4, we're going to rotate region S around the y-axis. So you can see we have this little symbol down here that shows that we are rotating it around the y-axis. If we do that, you can see our little radius is going to be this one here, and our big radius is going to be the red one over here. In order to get the big R, we're going to have to do right minus left. The right is going to be x equals y, and the left is just going to be 0. In order to get the blue radius, I need to do right minus left, but the right one is not solved for x. So if I square both sides, I'm going to get that x is equal to y squared. So the right is going to be y squared, and I do minus, and then the left is just 0. Again, we don't have to put minus 0, so let's just delete that. Now I'm going to put one of these washers here so we can see how the washers stack up. There we go. So one washer is going to look something like this. and we're going to fill in those washers from y equals 0 all the way to y equals 1. So those are going to be our bounds. Our bounds are going to go from 0 to 1. And that's it. We're pretty much done, other than plugging in the big R and the little r. Let's go ahead and do that. There we go. There's our big R. It's just y. And our little r is going to be y squared. That's our final answer. Let's put a box around it. And now we're done. Let's go ahead and look at question number 5. For question number 5, we're going to rotate that shaded region around the y-axis. You'll see we have this little description down here. It shows that we are rotating it around the y-axis. If we do that, you can see that the little radius is going to be right here, and the big radius will be this one in red right here. In order to get the big radius, I do have to do right minus left. So that's just going to be 2 minus 0. For the little radius, I'm going to do right minus left, but I have a little problem. My function is not solved for x equals. It says y equals x squared, so I'm going to need to do the square root of both sides. And if I solve it for x equals, I'm getting x equals the square root of y. Of course, the positive square root of y would be the right side. That's the one I want. The negative square root of y would be the left side. I don't want that one. So we're going to replace y equals x squared with x equals positive square root of y. So now when I do my little radius, I'm doing right minus left. The right is just going to be square root of y. And then I do minus, and of course the left is just x equals 0. You don't need minus 0, so we can just erase that part of it. Now I'm going to draw one washer so we can see what one washer is going to look like. There we go. That's an example of just one washer. And so we're going to want to fill in these washers from y equals 0 all the way to y equals 4. So those are going to be our bounds. We're going to go from 0 to 4. There we go, and we're pretty much done other than just plugging in the big R and the little r. Let's go ahead and do that. There we go. There's our final answer. The big R was 2, and the little r was square root of y. Let's go ahead and put a box around the answer. There we go, and now we're done. Let's go ahead and have a look at question 6. Okay, question 6 is our last example. We're going to take this shaded region. We're going to rotate it around the x-axis, so we have this symbol here on the x-axis. If we do that, you see the little r is going to be this distance here, and our big radius is going to be this distance here. So for the big R, I'm just doing top minus bottom. That's going to give me 4 minus, and then the bottom is just 0. For the little radius, the top minus the bottom is going to be x squared for the top, then minus, and then 0 for the bottom. Of course, we don't need these minus 0 pieces, so we can get rid of those. There we go. And now I'm going to go ahead and draw one of the washers so you can kind of get an idea of the orientation. There it is. There's an example of one washer. So we're going to fill in all these washers starting from -2, ending at +2. And there we go. You can see our bounds go from -2 to +2. So we are basically done other than just plugging in the big R and the little r. Let's go ahead and do that. Okay, there we go. Our big radius is 4. And our little radius is x squared. So that's our final answer. Let's go ahead and put a box around it. There we go. Now all you need to do is just practice. Remember, it's not good enough just to watch me do it. You have to practice it yourself. And then you check the answer key and see if you got it right. That's how you build confidence. And most importantly, that's how you build speed. You have to get fast at these. You can't sit there and take 20 minutes to do one of these problems on the AP tests. You got about 2 or 3 minutes to do one of these problems. So if you're one of those people taking 15 minutes to do one of these problems, you don't have enough practice. So you're going to need to practice more.